Hello, everyone. Today I'm going to cover the topic that I discussed at the visualization course in the last year's summer school. So it was a full-day course. My colleague Tyson covered the general introduction of ParaView in the morning, and in the afternoon I focused on how to get your own data into ParaView. So today I only have 1 hour, so I try to squeeze it in the 3-hour course into one hour. So probably it depends on the time we have. Probably I will not be able to cover all of them, but this year we run our annual summer school at the McMaster. So I encourage you to take a look of the program. And there's a visualization course at the last day. And we will enhance the material that we used for last year. So welcome you to register. All right. So let's get started. So what is ParaView? So most of you probably already know that it is open source, a general purpose visualization package. And I think the current version is 5.6. So, and it's very, very popular, and it has a lot of good features. Here I just mentioned a few of them. And it is well documented. So for new user, if you have a question, you can ask question to the mailing list. And also there's a lot of documentation like a wiki page and a guide and tutorial, etc. So it's very helpful. If you run into any difficulty using ParaView on our facility, please do not hesitate to contact support at computercanada.ca. We have a visualization national team to support you. And ParaView itself supports many formats. I think I did a counting last year. I think close to 73 formats. That's the total number of formats ParaView supports. But in any case, if you run into the difficulty that your own format is not in those 70 in the list, what you will do? So this is the topic we are talking today. So I will give you several ways to pull your own data into ParaView. All right. So before doing that, let's take a quick look of the internal structure of the data structure inside ParaView. So ParaView supports basically 2 categories of data. One is called structured data. The other is unstructured data. So for structured data, basically it has a very clear topological structure. You know, it can further divide it into like image data, rectilinear, or just a structure but a curvilinear. Okay. Under the unstructured category, you could have polygonal data or totally unstructured grid. So here I listed the extension of the file for different data type, and those are the ParaView its own data type, which in terms of VTK, because VTK is the backbone of ParaView. Okay, so it's a VT, and the last character could be either I means image, or R means rectilinear, S means just structured, or curvilinear. or P means polygonal, or U means structured. So we are talking that later on. So here I just illustrate the concept. So you see we have structured either in 1D, either in 2D, like the first row, or in the second row is in 3D case. So the first column, we can see that the grid points are equal spaced along each dimension. And in the second column, which referred as a rectilinear grid, the distance varying is not unique. And the last one could be any shape, don't have to be a straight line. So it's called curvilinear. And unstructured could be a lot of those. It could be line segment. It could be polygon strips, or and also some grids, structured or unstructured. Okay. So here is a full list of the structure that's supported by ParaView, and they call it a shared cell. So cell is the concept. Is something that you defined either as one-dimensional or two-dimensional, even three-dimensional entities. They are defined by points. So you can see that the basic element is points. It is in ParaView is most likely is defined in 3D space, and from those points, they can either exist as themselves, like points, like a VTK vertex, or a lot of vertices, or form a line polyline, or a triangle. A triangle is a two-dimensional. Okay. Then we can also form a cube, a voxel, or a tetrahedron, like those, different type of either 2D or 3D basic element. We call it a cell. So those are the types. And here, just some illustration of the previously the defined cells. I just color them like a VTK tetrahedron, which is in purple color, and voxel blue. You can see different structure here. All right. So cell is defined by, as mentioned, defined by one more points, and then form are either a 2D or 1D or 3D entity. And yeah, that's it. So so here is an example of a hexahedron. It's defined by 8-point data, and that formed one cell, which referred as a VTK hexahedron. Okay, so we could have attributes like temperature or density or whatever to associate with either point data or cell data. Point data is easy to understand. For example, let's say temperature. I put the sensors, a lot of sensors in the 3D space to sample temperature at different locations. So I got the temperature associated with points. And for the cell data, I could say, for example, if you do some statistics, for example, the population in different city or regions, so you can have a 2D, rectangular cell, and on each cell you get the number of population on that cell. So population is associated with cell. So I just give 2 examples how attributes could be associated with either point data or cell data. Okay. the attribute itself could be scalar, and it could be a vector like velocity, could be other things, even tensor. Okay? So what we could do if we have data that is not recognized by ParaView, we have different options. ParaView itself can import your data if it's already in CSV or in raw data format. I will demonstrate that. Other than that, we can convert your data into one of those recognizable formats by ParaView, like either the VTK format or some non-VTK format like NetCDF. There's some other format that's supported by VTK if you prefer to convert to any format that VTK ParaView support. All right. You can even instead of write a converter to convert your data into the recognizable format. Another is you write a plugin that you, because of ParaView support plugin, so it will do the conversion online instead of explicitly converted to some another format. So, but we will not be able to cover the last topic. All right. So now I think I will do the demo. I will do this. So actually, this is a good opportunity for me to demo, our VDI system. Most of our users are familiar with our cluster where you submit batch jobs, but VDI is the system that we set up for interactive tasks. For example, visualization that I'm going to demo today. So I use Tiger VNC to get on our VDI. Because it's quickly, I just repeat that address. It's grid-vdi.computecanada.ca. So you can get on that. So here, you use a module command like we do before. You can do module avail. And then, you need to load the standard CC software stack, because ParaView is one of the software on the stack. So I load that one. Let's check. Let's load ParaView. I load the 5.3 version. All right. Let me see where I am. So let's go to project one, summer school 2018 visualization. So here I have my data and the demo code here. So I'm larger. All right. So now I'm gonna run ParaView. All right, so here we have our ParaView GUI. Unfortunately, I cannot change the font, so the font size is a little small for you to, but I try to speak them out. All right, so first of all, let's take a look of CSV files. So I take the first one, very simple one. Okay, so probably you didn't see it. So I check first. Let's check this file. It's called one-simplest CSV. Is comma separated value format. The content is very simple. We have 3 columns. Each column represents the X, Y, and Z coordinates. So I have 8 rows. So that means I have 8 points. So those 8 points define 8 points. Sorry, it's 8 points. So this is the simplest one. So let's load it in. I click this one, load it in. Here I see, you have, because it doesn't have a header, I uncheck that one, click apply. So this is what I get. So after load the CSV file, I got a table object like this. So it sees, because it doesn't have a header, it named the first column field 0, and the second one is field 1, the third one is field 2. So all the values are appeared here. After that, you have to convert your table object into a displayable object using filter. So here I go to use from table to points. Here is the GUI. Once before you click on the apply button, you have to specify which one is the X column. I say field 1 is, field 0 is, Y column is field 1, Z column is field 2. After that, click apply, and then the 8 point. Probably you couldn't see her. You see the 8 white dots in this small window. To make it more visible, I make the 8 dot become 8 balls. So I can do that by using the glyph filter. So here, choose the glyph instead of arrow, but I choose a sphere. Apply. Yeah, I got 8 balls as points. So that's what I got. So you see, it's very simple. Now I basically hidden them. Now let's take this. What if I have something with a header? So nothing's changed. I just add a new line in the new row, which specifies the column. So let's see what we have. I load that one. Header, yes. This time, remember, don't uncheck this one. So I keep this one checked. Means have headers. Apply. So now you see, instead of field 0, I have a Y, Z, and X, but the order is some kind of, I don't know why ParaView does that, but it's the same thing, okay? And once we have the table, we can do the convert to a displayable object as well, from table to points. But this time I choose to convert it to a structured grid. Then you can see the difference. So here I see the extent, because it's just a cube, not a cube. It's a structure, topological structure is a cube, but the coordinate is not. So it's a general hexahedron. So I choose those, but I need to specify which one is X, Y, and Z, and then apply. And then I make it visible. So it's the same thing, just if I make the cliff visible, the previous one, so they match perfectly. Okay, so it's basically the same thing, but I just have a header. All right, so I'm gonna hide those, and then let's take a new thing, which I call header plus attribute. We call it pressure. So normally, you see I have a new column called pressure, and I add a value for a third column. So the reason for that is it usually makes sense to have some property or attribute associated with the geometry. Otherwise, it's just geometry. It doesn't have any physical meaning. So here we have a physical meaning. So let's do it one more time. I just close this one, mute everything. Now I'm gonna load the pressure here. Header, blah, 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 should be good. So I got here, you see. I have those columns. I have a new column here. Oh, sorry. Sorry, I shouldn't do that. It's called so it's called pressure, right? And for this one, I can do exactly the same thing, convert it to a structured grid. I do the same thing. Now X is Y, specify X, Y, Z as before, apply, and yes, and then make it visible. And now we could see something more interesting. Instead of display this as outline, I can display as surface. But by default, it doesn't show anything interesting because you use solid color. You can color it with a pressure. This is what I have. So I make it a bit larger. You can see better. So this is the thing we have. You can see one point is have the highest pressure is colored red. So this is this is the thing. So you can see here we have the pressure highest at 7, the lowest is 0. So you see basically this structure. All right. So I just demoed something, and you can even make it fancier to have not just one attribute. You have multiple attributes. So here I had one more. I call it pressure and the temperature. Okay. So let's do that one. So clean up a little bit. I'm going to load this one. I call it header pressure and the temperature. Yeah, just this one. So let's see if I have anything to change. No, I apply. So I got this correctly. And I do exactly the same thing. One, X, Y, and Z, apply. And now we have this one. And instead of outline, I want to show surface. And instead of solid, oh, I do something wrong, right? It becomes, whoa, what's going on here? Let me check. Oh, sorry. You see what? I made a mistake. X, Y should be Z. I put it X, so it's wrong. So X, apply again. So now we got it. All right. So one thing you mess up, you won't get the correct result. All right. So here I have surface, so solid color. I can color it by either by pressure or by temperature. So you have different way to show the result. All right. All right, let's see what so that's for how to import your data that is already in CSV format. If you don't have, if your data is not in CSV, but it can be easily converted to CSV, you can do the trick. You can do the conversion and load the CSV the same way as I just demoed. And now I'm gonna show you how to load raw data, raw file. Okay, so let's take a look of the C code. So Although some of you are not very familiar with C, but it's not, it doesn't matter because I can explain it. So here I'm gonna to create a regular grid. Okay, it's a grid set of you know, I give the 43 by 30 by 60. That's some numbers. So I'm gonna create a big array. Here I'm gonna create a big array. I call it A. The big array, if you know C, you know that actually I do a malloc to ask the system to allocate this memory, which is size is D max times D y times Z times the size of float, which is 4 in this case. So it's basically create a big array of type of float, size of 43 by 30 by 60. Now I'm gonna to fill up the array with some value. To make it interesting, I use a lot of cosine, exponential, whatever. But this part later on, if you want to use this code, you can replace this part to fill in your own data into the array. You can also adjust the size. If you don't like this size, you either make it larger or small. It's up to you. But I just demoed the basic idea. You know, I have some value in you know, it's in a regular grid. I'm gonna fill it up, and then it's very simple. Basically I open the file as a binary. You see it's a B, and then just write the big array, which is A, right? The A is the big array. I write it. It's 4, okay, as a float. That's all. After that, I close the file and return. So it's a very simple one. Just ignore the other thing like a pi or widths that I just make it interesting. I use sine, cosine, you know, as a parameter. So basically, it's quite a simple one. So let's run it. I already compiled it. I got this one. So I run that one. I give a name. I call it aa.rar. So that's the one. So it's done. I see there's a file just created as a result of running this demo code. So now I'm going to load it in. But before doing that, I'm just gonna clean up. So there's on the edit, there's an easy way instead of you know, create the program and restart again. You can reset session, and everything's gone back to normal. So it's kind of reset. So here I'm gonna load the file aa.rar. So very important. Once you select that file under the panel on the left, you have to do something careful. First, you have to specify the scalar type, which is a float, because as I said in the it's float. I already showed the code is float. Secondly, the dimensionality is 3-dimensional. I don't need to change that. That's the default. And you can also specify the date origin, which is 000. I don't want to change that. You can change the spacing 111. You can change that, but it doesn't matter. I don't want to change it either. But here, the date extent, I have to change it. Let's take a look again of the. It's 43, 30, 60. So here, I need so from 0 to 42. Oh, sorry, 42. The second 30 is from 0 to 29, and the last one is 59. Let's check anything else. Okay, The last one is the scalar name, because I just have an array. I didn't say anything about the physical property, because the raw data, it doesn't have the ability to specify what the physical meaning. But here we have a chance to specify, suppose it's density, no matter what density it is, or temperature, whatever you want to say. I give it a density, then click apply. Okay. So here I got my first display because it is offline. You just see nothing interesting. But once you say I want to give it as surface, then select solid color, replace solid color with the density. So that means I want to color. Oh, something wrong with this line. What's going on? 40, 21, I think to have something. Oh, sorry. I see one thing I missed. You see the endings. By default, it thinks the data is a big ending. Actually, it's not. It's a little ending because our architecture is Intel. So it's, let's do it again. Okay. And then apply, and then density, and then change. So now, because the scales have changed, so now I see some interesting pattern here. As I only can see the outside of the box, but it's really interesting something inside. So to see the inside, I need to use the volume rendering instead of surface rendering. So now I can see inside. Okay, so we see the inside. For volume rendering, you can basically adjust the opacity or transparency to see either more opaque thing, or you can see only the core, the high density part. So it's up to you. You can adjust not only the color but the opacity. So it's all at your disposal. You can control everything. All right. So this is the result. All right. So this is we just covered how to load the raw data. And because raw data doesn't give any information, but the big array, it only can use to load graded data. But if you have some arbitrary structure, unstructured, you couldn't do that. So what the other option is, we use the native format that ParaView support, which is the VTK format. We have VTK legacy format, and also VTK more than latest format, which is XML-based format. So first, let's take a look at the legacy format. So it's very simple. I show an example here. It's an ASCII. Here is the ASCII file. The first one, you must use this one. You use VTK data format for specify. I think the latest version is 3. And you specify what's the second line is a description. You can put anything there as long as it's within 256 characters. That's fine. And the third line, you specify the format, either ASCII or binary. So here I use ASCII, and then you specify the type of data set. You say here I want to use structured points. The dimension is a 2, 2, 2, like a 2 by 2 by 2. And the spacing here is along the x direction, spacing is 2. But here it doesn't matter because it's only just one box, so it doesn't really matter. Then along y is 0.6, and I give just 3 values here, separate by space. And then the orange of the box. After that, you have to specify cell data, because here it's just one structure data, one cell. But I do not have any attribute for the cell. And I have 8 points. And then for the 8 points, I have a scalar to associate with the 8 points. I said that the scalars, I only have one. I name it temp. I refer temp as temperature. You can use any other density or whatever. And you have to specify the type. I say it's short integer. And this one is you can have it or you don't have it. It doesn't matter. It's specified. The last one is specify the temperature. You just specify because you have 8 points. You have 8 temperatures. Here I give 8 numbers as temperatures at 8 points. So that's it. So let's load it in. I have this one. I load structure points. Apply. So this is what I have here. Instead of I said, oh, sorry, I have to select surface. You see, we have something here. So it's just a box, but it's actually a regular grid. But it's regular grid doesn't extend too much. The extension is from 0 to 1. So that's all. Let's take a look at a second example here. We have, let's take a rectilinear. So for rectilinear, as I said, the distance could be, the grid point could be not equal deep distance. So that means we have to give along each dimension, we have to give a sequence of coordinates. Because for x direction, I have extension 2, so I only need to give 2 numbers. I give 1, 0, the second 1. For the second dimension, I also is times 2, 2, 2, so I give 2 numbers here. So basically, this is the only difference from the previous one. All right, so let's load it in and let's see what we have here. I hide this one. I load it like linear grid. Click OK, apply, and then I show surface, temperature. So this one should be exactly as the previous one, as this one. So I hide this one, show that one. So you see, I switch back and forth between these two. Actually, they are the same. The reason is, as I said, I choose the same, although it's different. But here I choose the same parameter, 0.6 and 1.3 as the distance. So, let's answer that question. So now I'm gonna move on to show some more interesting stuff. Now the last one is just structured, but I do not guarantee the orientation. So for that I have to define the 8 points because they don't have necessarily to be on a straight line along each dimension, which means it's curvilinear. So I have to give the coordinates for each grid point, because here I have 8 points. I give 8 coordinates. So let's load it in again. Okay, so it's a for structured grid. Yes, load in, apply, and show as surface. So color temperature. You see it's a general hexahedron, which is not a cube. It's a oblique cube. You can see that. So here I just show some way to create a 3D data file in the VTK Legacy format. But the thing is, if you want a copy edit, basically you only need to edit the header part and change some parameter. And after that, this could be a long list of your grid, either represent the temperature or whatever you want to represent. So that will be good enough. So it's not very hard. But if you want to, for example, if you want to create a large amount of data, you have to find a way to write it more efficient. Instead of ASCII file, you prefer to write it in a binary file. So here I show an example, a C code, to show you how to do that. So here I basically I do pretty much the same example as I do for the previous raw data format. Basically, I create exactly the same type of regular grid, exactly the same size. Okay, but in here, after I fill up the big array, I call it the A, the same way as we do for the raw data. But instead of write it up as a binary, here I play some tricks. So I open it as also as a binary file. But when I use fwrite, I actually write some characters. First, I do exactly the same thing. I write the first line as characters, and do the exact same thing. And based on whether or not you want to write binary, and the binary, if actually I use as a option of the program, I can either write binary or ASCII and whatever. And finally, write everything, just repeat the previous one. Finally, I write the data. If I really want to write a binary file, simple. I just write it out like that. If I want to write ASCII, I have to do it this way. So write it as a character. So that's the program. All right. So let's run it. And okay. So here it prompts me with the usage. So the prompt usage is first I give a file name that I want to generate as a holder for the result data, and then I can use either -b for binary or -a for ASCII. So that specify what type of So I said VTK Legacy format. I use VTK. I use this file name, and I say I want binary. Do that. Oh, sorry. Let's check what we have. Okay, we have this one. So let's load it in. Before loading it, I uncheck this one. I open VTK. This one is the just generated. So click add one, apply. We have this one. Then change it to surface. Select temperature and rescale it. So you see what we have exactly as we have before, and we can use a volume rendering. You see exactly as we have before. So to make to prove that, I hide this one and unhide the previous one, the raw data. You see, we have exactly the same one, right? Exactly the same one. All right, so that's a way we have to use a code, C code, to write our data in legacy format. Lastly, there's some others examples, like how to write VTK XML format. Because we don't have time for that, I'm going to skip that. So just a reminder, you can come to register for this year's summer school. We will cover the full range of everything there. We have like 10 minutes left. I'm gonna do a last demo, is how to write data into NetCDF format. So NetCDF is a very cool format. It has the ability to, a lot of flexibility there. You can also choose, compression, etc. So the code itself is pretty much similar to before. I use exactly the same parameter, 43, 30, and 60. And the way we fill up the big array is the same, but the only difference is the last part. So let's take a look at how we do the NetCDF. So first you create a NetCDF file handle by give a file name. Okay. Here I specify if it already exists, I can replace it. Then you need to specify from the handle, you specify the dimensionality along X, Y, and Z. So here I switch it because it's always from the last Z coordinates. So I specify it in this way. And lastly, you just add the one into it, and then write the big array A into it. That's it. So here you specify the big array you want to specify. Say its density, type is float, and the dimensionality that you already specified here. Okay, it's very simple. You can find the source code I posted afterwards. You can get the code. You can practice yourself. All right, so let's run it. Okay, I have this one. I need to specify a name. I say to BBB. And NetCDF usually by default is .nc as is the default extension. So I followed that convention. So here I have BBB. Let's load it in. Here I do this BBB.nc and load it, and it asks me what kind of NetCDF it is. I say it's a generic. Okay. Click OK. And anything else? Apply. I think that's it. Apply, surface, color, density. You see, we got exactly the same result. If you do volume rendering, yeah, exactly the same volume. So basically, we generated this regular grid in 3 different ways. One is just raw data. The other is in the VTK legacy format. Last study, we put it into NetCDF format. So all of them can be loaded into ParaView, and we get exactly the same result. So I'm going to stop here because I want to leave the rest of the time for questions. If you have any question, it's time for you to ask.